Hello, my name is Brian Dougherty. I'm a field agricultural engineer with Iowa State University Extension and Outreach. And today I'm going to just briefly discuss improving soil structure and water management and talk a little bit about why that's important to you as manure applicators. So if we think about water management on our farm fields, there's really two goals that we should try to shoot for. And one is to increase the infiltration rate into the soil. And the second one, from more of an agronomic standpoint, is to try to maximize the amount of plant available water that's held in that soil. And I'll talk a little bit about how we can go about doing that. But, ideally we want to maximize that amount of water held in the soil between those soil particles, because that can help increase resilience to drought stress. And then once we get to that point where you can see in the graph there on the right, we get to where what we call gravitational water, and that's when that water starts flowing through that soil profile, deeper into the profile or into our tile drains if we have drainage. And we want to be in a situation where that water moves through that soil as quickly as possible, so we don't have water ponding on the surface and we don't have a lot of surface runoff, because that'll delay our ability to get back into the field. So if we think about achieving those water management goals, there's really two things to focus on. One is to try to increase the amount of organic matter in the soil, because organic matter can hold several times its weight in water. So the more organic matter you have, the more water holding capacity you're going to have in that soil. And the second is to increase the amount of soil aggregation that we have, because that improves the ability of that soil to infiltrate water. And has a lot of other benefits as well. Those pore spaces allow for more air, more oxygen into the soil, which also is a benefit for crop production. So the way we do that is by implementing what are often referred to as some of the soil health principles. And the main ones we're concerned with here would be reducing disturbance. So we're mostly talking about tillage in that case. Keeping that soil covered with residue that helps to armor that surface, prevent damage to the soil surface, prevent erosion, and then keeping a living root in the soil throughout the growing season. And here in Iowa, we're mostly corn, soybeans. We're mostly talking about cover crops in that case to fill in those gaps, on the shoulder seasons when we don't have a cash crop in the field. So I mentioned soil aggregates earlier. What are aggregates? Well, a really simple way to think about it is they're just clumps of soil particles. So they're sand, silt, and clay that are glued together or stuck together in the soil by organic matter. And it's actually a biological process that makes that happen. So these aggregates, they can be various different sizes and shapes, and they have a pretty irregular arrangement in the soil. And so if you look at the image there on the right, that's a very well aggregated soil. It's got a nice dark color, so that's an indication of high organic matter. But if you think about water flowing through that soil, those irregular shapes, the different sizes of aggregates, really create a lot of pore space in that soil, a lot of channels for that water to infiltrate. And it's often described as having sort of a cottage cheese look. So if you go out and you dig up some soils, that's something you can look for. Does it have that look to it, or is it very blocky and platey and a lot of restricted layers in there that prevent that infiltration? So how do we improve soil aggregation? I mentioned this is basically a biological process. It's really the combination of plant roots and soil biology that build soil aggregates. This isn't something that will just happen on its own. You have to have an active biologically functioning soil to build these aggregates. So one component is the plant roots. I like to think of those as kind of the framework in the soil. They kind of hold that soil together, help prevent that erosion from the surface. But a bigger part that comes into play here is actually the interaction between the plant roots and the soil biology. So plants actually leak or exude carbon, or they're often called root exudates, into the soil. And that carbon is a food source for the microbes. We're mostly talking about bacteria and fungi here that do a lot of the legwork, you could say, for building these soil aggregates. But the combination of those root aggregates, secreted into the soil, and then that biology consuming those, dying off, being consumed, they create sort of a glue that holds those aggregates together. So that's how soil aggregates actually form. And then where tillage comes into play is that, the more tillage you do, the more you disrupt those soil aggregates, And so it's kind of like hitting the reset button. If you till that soil, you're not going to break up all of your aggregates, but you will cause a lot of disruption. You'll break up old root channels that were allowing water to infiltrate. So the more we can reduce that disturbance, the better our water infiltration rate is going to be in the long run. So you're probably thinking, okay, this is great, but how does this apply to me as a manure applicator? Well, there's several things that come into play here. We don't have a lot of solid scientific data on this yet, but there's a lot of anecdotal evidence from farmers who have been going with reduced tillage or no-till systems and cover crops. So they're seeing much better trafficability in their fields. They're able to get out there sooner, in wetter conditions, because that soil has the structure to it to hold up their equipment. It's able to take in that surface water. They have less ponding. So just a better ability to get into the field, fewer ruts, less compaction in that case. And another thing to consider as a manure applicator is if you can get that water to infiltrate, you've got less risk of a surface runoff event, potentially causing a water quality impairment. And ultimately, what we want to get to here is just more days to apply manure. So if you've got better field conditions, you can get out there sooner. That opens up more windows of opportunity to apply and potentially be able to do that, with less damage to the soil, less compaction, because that's really what, you're going to care about from an agronomic standpoint. And let's face it, nobody wants to be this guy where you get stuck and you got to call somebody to come and pull you out. It's a hassle, it creates a lot of damage out there. So we want to try to avoid those conditions if at all possible. Here's just kind of a visual representation of that. So this is a side-by-side picture during a rainfall event of a field on the left with no till and cover crops. The field on the right, is tillage, no cover crop. So you can clearly see the runoff, going down the waterway there on the right side. And that water basically disappears when it gets into that no-till cover crop system. So obviously you wouldn't want to be out there in these conditions, but just think about that. Which field would you rather, be out there operating on, once that dries out a little bit? It's a pretty clear difference between the two systems. So then that all sounds great, but then how do you know if you have good aggregation or if that's something you need to work on? There's some really simple assessments that you can do in the field. It doesn't take a lot of training. This is something you can do yourself. One's what we call the spade test, and that basically just means go out and dig a hole and look at your soil. You can see the image on the right there, some different, soils that were pulled up with a shovel. These are all the same soil type within about 200 feet of each other, but you can see the one on the right there clearly, is lower organic matter. It's a lighter color. It's got more of a blocky structure. That soil is not going to infiltrate water like the ones shown to the left of it. So something really simple you can do in the field, just take a shovel, keep it with you in the pickup, and dig some holes and just observe what's happening out there. Other ones you may have seen are the slake test. That's just dropping a clump of soil into the water and seeing, how long it takes for that soil to fall apart, or if it falls apart. That's a really good indication. You want that to stay, intact. If it dissolves and falls to the bottom, that's a really good indicator you've got poor soil aggregation. You can also do an infiltration test. That's just a quick infield test. You pound a ring into the soil and you just time it and see how long it takes that water to infiltrate. But we're going to show a video here in a minute that's going to go through the slump test, which is another way to assess how well your soil is aggregated. It's a really simple, easy, quick way to get a visual assessment of aggregation. And then the other one is an infiltration test. So this would be similar to the ring that you would use out in the field where you time it, but this is more of a visual demonstration. A little bit more sophisticated equipment here that you're probably not going to buy for yourself, but it's a great way to visualize what's happening in the field. So I just want to give you some context for what you're going to see in the video before we play it. So these are cores that were taken from the Northeast Research and Demonstration Farm near Nashua. We've got several different treatments there. So the one you see on the left, that's a continuous corn system. It's in strip till for the first year. So prior to that, it was just conventionally tilled. And it's got an early season interseed, so around V5 interseed, multi-species cover crop, so that was a 9-way mix. The one in the center is the same treatment, continuous corn, first year strip till, but no cover crop. And then the one on the right is a treatment that we've had in place for 12 years now that's in corn soybean rotation, and it's had a fall cereal rye cover crop over that 12-year period. So just take a look at the video and watch and see what happens, which ones have more runoff from the surface, which ones infiltrate water better, and also take a look at the clarity of that water and see how much sediment is in that runoff. So I hope you enjoy the video, and thanks for watching. I just pulled these cores this morning. These are from the plots that we're going to be going and looking at here in a minute. So we've got our 60-inch that's got the actively growing cover crop on it. And that's the strip till. And I've got, for comparison, I've also got a strip till with no cover crop. And then I pulled one from our kind of longer term fall cereal rye treatment. So that's been no-till with cereal rye for 12 years now. And so basically I'm going to add 1 inch of water and we're going to see what happens. Just kind of full disclosure here, it's very dry out there. So when I dug these up this morning, it did kind of fracture the surface a little bit. And so you're probably going to see more runoff and more soil going through than you would in its natural state. You can see we've obviously got a lot of macropores and a lot of infiltration there because that one's going straight through surprisingly quickly.
Are they all dry zones or non-dry zones? Or?
These were all, I tried to stay out of the wheel tracks. These are right in the center, so they're strip till, but these were undisturbed for the most part last fall. This did have manure injected into it.
They were taken
between the strips. Yep, this is not in the row. So we got any gamblers here? Who thinks this one's going to infiltrate the best? It's pretty amazing how quick that's going through the profile. You can see we got basically zero runoff here. This one, it looks like almost all of it ran off. We'll add another inch here quick.
How many years has that middle one been undisturbed?
Oh, this is the first year that these have been in strip till. So that, great question. So these were full width tillage, you know, cover crop, no cover crop. These were full width tillage, continuous corn, you know, prior to this. And so there has been a good amount of disturbance on these soils. Now we're getting some runoff with our cover. So not everybody's gonna buy one of these kits. Obviously this is a bit expensive to have, but it's a nice demonstration just to show the difference you'll see between the different treatments.
Looks a little lower cost than the trailer, I see.
Yeah, this is true. And so I had no idea what was going to happen when I did this. This is the first time I'm seeing it as well. Okay, so our 12-year no-till cover crop took an inch of rain. And as quick as that would go, the second inch, we're starting to see a little bit of runoff, but look at how clean that water is. That's 12 years of no-till and fall cover crop. So again, just kind of shows the difference. So this is something you can reasonably do at home. Very simple, easy demo. So these little sink strainers are about $3. Works a little better dry soil, so I brought these with me, but I've got just a comparison here. This is corn soybean annual tillage. This is a corn oat alfalfa rotation with tillage during the corn years, and this is from a grass buffer strip that was actually pulled right out here. So what you do for this test is similar to the slake test, which I'm sure you've all seen. But you don't have to have the tall cylinders, you don't need anything fancy, just a mason jar and the sink strainers. And so what you want to see here is basically these aggregates hold together. So You can probably come up a little closer here. You might be able to see it, but you'll see some bubbles coming out of the aggregates here, and that's basically water moving its way into those pores that are inside that aggregate and forcing the air out. And so that will cause a little bit of dispersion. And so again, so basically what you do is you just leave this for a minute or so, and then I'm going to flip them over onto these plates here, and we'll see how well they held together. And these were very dry, so I'm just going to leave them for a couple minutes. So any questions, comments?
While you're waiting on that,
You bet.
what was the cover crop that you seeded into the continuous corn no-till?
Cereal rye, fall cereal rye. So yeah, just single species.
You're terminated a week before planting.
Yeah, so that cereal rye is terminated 10 days to 2 weeks prior to corn, and give or take a couple days on the soybeans. So pretty standard management on the cereal rye. So for the sake of time here, I'm going to go ahead and flip these over, and we're going to see what happens. So this is our corn soybean rotation with tillage. Here's corn, oat, alfalfa. And here's our grass buffer strip. Now I'm guessing these maybe didn't even soak all the way through, but then you can just kind of poke at them and see what kind of aggregation you have. And if you can see this, that essentially just turned to mud. There's no structure in this soil at all. You wet it down, so when you get a heavy rainfall on this, it's going to disintegrate, the surface is going to seal, and you're going to have a lot of runoff. Our corn, oat, alfalfa, holding together much better, not falling apart, so better aggregation there. So this soil is going to handle a rainfall much better. Again, same thing with our grass waterway, so that soil is holding together, it's maintaining its structure, and it's able to take in that water without falling apart. So again, just call this a slump test, similar to the slake test. Really quick, easy demo you can do at home in 5 minutes with $10 worth of equipment. So I encourage you to just try this out with your own soil. It's always good to have a reference area, so get some in your field and go to the edge of the field that's been undisturbed, grass waterway, whatever, and pull a sample there so you have kind of a baseline to compare to for your soil.